Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this episode, we're going to be taking a look at this. Now, this is not quite an unboxing. This is a review, I would say. We're going to be taking a look at Snap Circuits. The Snap Circuits Junior. Basically what this is, it's a toy, a very cool toy, learning about all sorts of different circuits. I also would find this thing very useful for possibly prototyping, like some electronics projects that I might want to do. So I guess without further ado, let's get into this video. Alright, so here's the front of the box. Now, before we get into this, I just want to say this and this are kind of misleading because when we get into the box, I'll show you these two parts are actually red. So kind of a bit little that's my first little complaint about this, but it doesn't really affect the functionality of it. Let's open it up, and so the first thing you see is the instruction booklet. So basically in here you got all your things, some warnings. This right here, very useful, is a pinout of the ICs, which are these three things over here. Basically they're for triggering sounds on the speaker, but they can also be used to they can also be used in some circuits to like work an LED, for instance. Yeah. So if we open up the book here, I think how this episode is gonna work is I'm gonna go through and point out some of the coolest circuits that I think are in here. Plus, also, there's one other which I really do like. But yeah, so let's get started with the first circuit. But before we get into this, to starting to build circuits, dudes, not all of these parts are mine. Some select parts, like this press switch right here, basically, I'll pull the, this is what you build on this. It's like a, sort of a grid, like, it's got little nubs on it so that basically things can stick on it, but as you can see, it's like a button. It can turn things on and off, like, when it's pressed, and this will turn on, and, well, other way around, but still, let's shut that off. But yeah, not all of these things are mine. So this and this are not mine. I borrowed it from somebody. Maybe one day I might buy some of my own. But yeah, and also if you look over here, there's tons of stuff. The Snap Rover, basically it's this base, this motorized base, and it has like the base grid on it, so that you could build your circuits. And basically there's this like controller that you put all your inputs to, and there's like snaps, as they call them, on the back, and you can bring your jumper wires down to there, and basically that's how that works. And there's tons of stuff in these things, like there's also lots of very cool parts, like for example, Focus, focus. Okay, well, this part right there, that is a diode. So instead of like this, which lights up, this emits no light. What it actually does though, it only allows current or energy to pass in one way. What that's really good for is turning alternating current to direct current, which is alternating current is what comes out of your wall sockets, and direct current is like from a battery, like, yeah. And I guess let's see what else is there. There's also this one part which plugs into your wall. It's called a battery eliminator. Basically, you don't need these goofy double A's anymore. I will totally be getting that. Anyways, let's see here. Got what else? There's a 7-segment display, which I really like, and yeah. But anyways, let's get started, and let's build some circuits. One of my favorite circuits is this little light circuit. Basically, it's this battery hooked up to this light via 2 jumper wires. I don't know if you can see them right there. There's red and there's black, and then they go to this light, and basically it makes like a little portable light circuit. You can take this battery and like toss it in your pocket, and you can like carry this light around with you, light up certain things. It produces a good amount of light. It's not as bright as you're seeing it. It's okay for some things. I wouldn't make it a flashlight though. But yeah, pretty cool circuit. I really like it. Alright, so the first circuit that I want to show you guys is this circuit right here. This circuit is Project 5, which is called Lamp and Fan in Series. So as you can see, when I turn this on, this is very slow. Not half as fast as it should be. And this light is also pretty dim. So basically, what series is, what's happening in here is basically the voltage is shared between the two. So they're both sharing the same voltage. So it's basically like this won't be able to get the full voltage of the batteries because there's only one path that voltage can flow. So it's kind of slower than it should be. So let's move on to the next circuit, and I'll tell you the differences between this one and the other one. Alright, so this next project is looks like this, which is called which is Project 6, and it's called Lamp and Fan in Parallel. The way this compares to the other one is, well, it's pretty much self-explanatory. When I turn this on, this motor is spinning a lot faster than it normally would be. And the light is somewhat brighter, but not really. There still might be a voltage drop, but this motor is spinning a lot faster. So how this compares to the other one is, well, let me shut that off so I don't have to be yelling. Basically, in this one, the voltage is shared, and in this one, the voltage isn't shared. The only difference is the current in here and in here is a little bit different, but that doesn't affect the running of it. I think current is the size of the circuit, which I don't think that would affect it in any way. But yeah, let's move. And also, some of you who are watching this video and are in my science class may know this. But yeah, let's move on to the next circuit. Alright, this next circuit is called light emitting diode, or I guess the light emitting diode. The name is light emitting diode, but still. Project number 7, and basically what this is, it's a light, but it's a special light. It's a red light, but it's not like your normal light bulb with a with tinted glass around it. It's basically it's a diode, but it's the diode that lets out light. If you look over here also, if you take this apart, and you turn it around, nothing happens. The switch is on, as you can see. I'm turning it on and off. Nothing is happening. The reason for this is diodes only allow current to flow in one direction. So if you reverse the polarity of this, it basically won't do anything. And this part is very crucial to this system. If there was no resistor, this would die immediately, and that would be basically wasting your money. So it's pertinent that you use a resistor in front of an LED. I have never tried it without a resistor, but I don't want to waste my money or find out what happens. So I'm just gonna not do that. Yeah, so let's turn it off and I'll show you again. Turn that around like so, and like so, and as you can see, turns back on again. Pretty neat. A popular use for this is, I don't know, I guess, like on your phone, for example, or like, I don't know, there's on my camera, on the back of my camera, there's two little lights, and those are LEDs. On my AV3, oh, let me grab it. Oh goodness. Oh, good lord. This button here is lit up with LEDs, and so yeah, there's lots of applications for LEDs. But let's move on to the next circuit. Alright, so for this next circuit, I moved over here because this circuit is, I don't know, it's pretty cool actually. It's called Flying Saucer. Basically what it does is, instead of the air being pushed up here, it's being pushed down, therefore pushing the blade upward and flying away, kind of like a flying saucer, which is exactly what it's called. So, let's try it out. This may take a while. Oh, okay, never mind. Hold on a minute. Let's try that again. There we go. Okay. Waiting. If you put your hand underneath even, you can feel the wind being pushed down. It's quite the force, but you know. Oh, there we go. So there we go. And yeah, so let's move on to the next circuit. Alright, so the next set of circuits that I want to show you are projects 47, 48, 49, and 50. Basically, these circuits are all, well, how your computer does what figures out all the things needed to get outputs to your computer mouse, or your, well, not your computer mouse, your computer mouse is a monitor that can be used, like, for example, for these two. However, it's basically, this is an OR gate. What an OR gate means is that either this or this can turn the LED on. Yeah. So yeah, basically, if you look at the path of the energy, it can go either this way, or it can go this way. This next circuit is a AND gate, and what this does is, both of these, this switch and this button. Oh, wait, hold on a minute. What's going on here? Oh, right. Basically, this switch and this button have to be pressed for this to turn on. If the switch is off and you press the press switch, it won't work for either of them. If you turn this on, but with this not pressed, it won't work. Basically, this and this have to be pressed. That's why it's called this and that. Let's move on to the next circuit. Alright, so these next two circuits are the exact opposite of these circuits on the reverse of the page. Basically, the LED is on instead of it being off when these are pressed. So this is a NOR gate, and what this is, the LED is on until either this or this are pressed. And then, of course, both of them can be. In fact, cool trick. If both of these are pressed, oh well, huh. Oh yeah. So anyways, I thought it was like, so yeah. And of course, if both of these are pressed, it doesn't, it's off. So basically, it's the reverse of an OR circuit. So let's move on to the next circuit. And the final circuit in this series is the NAND gate, the reverse of a AND gate. Basically, the LED is on until this and this are pressed, and then it's off. If one of them is on, it's on. So yeah. All of these circuits are called logic gates. They're pretty useful in computer circuits. Yeah, so let's move on to the next circuit. And yeah. After I'm finished building the circuits, I'll hop onto my computer and I'll show you dudes about some of the parts that I think are pretty cool. So let's get into that. And this final series of circuits I want to show you is this light controlled lamp. And also there's two others. Probably I'll only show you this one. Maybe, I don't know. Probably not. Probably I'm just going to show you this circuit. Basically what this circuit is, it's controlled by this music IC, and this is a example of how these may not always have to be used with a speaker. Basically, what it's doing is this acts as a light detection circuit. So as you can see, if you see there, that little thing is lit up in there. So when I put my hand over it, it goes away. Basically, there's this part which is a photoresistor, and basically it only in this case it only allows energy to flow when there's light present. Possibly, if you rebuilt this circuit in some way, you could invert it so that if there is light present, this light is off. And a popular use for that would be, I don't know if you know, on some houses how if it's when there's like a sensor like outside, and then when it gets dark out, it turns, the sensor detects that and turns the floodlight on. It's pretty cool. But anyways, now let's hop onto the computer and I'll show you some of the parts which I think are pretty cool. So let's start that. Alright, so I'm here on the Snap Circuits website, and so the first thing that as I was saying when we were looking at the back of the book, there's a lot of parts. They've certainly been keeping up to... Snap Circuits has certainly been keeping up to date with all the recent electronic parts. So they got like solar cells, they got rechargeable batteries, they also have, as I was saying earlier, there's this like power adapter that plugs into the wall so that you don't need a battery. This is the snap module that you would use for that purpose. If we pull it down, there's also a 7 volt version of that solar cell. If we go over one more, we have a couple of base grids. We have capacitors. What capacitors are is basically they can hold a charge. They're similar to a battery, except they're only meant to hold their they only hold their charge for so long. So there's all sorts of values. Basically, there's different capacitance values, and it's measured in farads. Now, a farad is a massive number, so to make it smaller, it's a microfarad. That's what this U here is for. There's also a compass, and this is very cool. This is a variable capacitor. I'd be very curious as to how it works. I assume there's that knob right there which increases the capacitance. I'm not sure though. There's a whole ton of LEDs. There's red ones, there's green ones, there's two color ones. There's also this diode right here, something that doesn't allow light to pass through it. But anyways, there's white LEDs, there's yellow LEDs, there's even here's another white LED, not at an angle though, like this one. There's also the 7-segment display, which is a whole collection of LEDs. Basically, there's one LED for each segment of the display. There's also a color LED, which I'm not sure, but in some cases this might actually be an RGB LED, or a red, green, and blue LED. Basically, it can light up in any color that you want it to. There's also blue LEDs, and there's fuses. There's also all sorts of jumper wires and lots of different kinds of lengths and colors. There's also audio jacks, which basically, I guess, I don't know, if you have your headphones, you can, there's parts in here to make a radio. So if you you can hook the radio up to these three ports, and you can hook headphones up to this, and it will play sound in your headphones. There's also all sorts of motors. So, like, here's the motor that I have. There's also I think somewhere, there's also an electromagnet, which I might try to do a project around. Also an iron core rod. There's a low-speed motor, which I assume it's... Now, this is what confuses me. This is probably not a brushed motor. Or probably is a brushed motor. It looks like a brushless outrunner motor, but the difference between brushed and brushless, I think I may have said this before, but a brushed motor is controlled by two brushes rubbing against a circular copper ring called a commutator, and that commutator is separated into different parts, and they're connected to coils, and those coils create a magnetic field which opposes the magnetic field of the stator. And yeah. We also have light motors, which I'm assuming when you turn your circuit on, as well as spinning, this will also light up the LEDs, I guess, on the motor. As you can see here, there's a little bit of a brown thing with white spots on it. There's also this 2-spring socket, which I believe would be useful for if you have like actual electronic parts, you could stick it in there and you could test if that part will work in the circuit like you want it to, and then when you're done, you can take it out of these 2 springs and put it into solder it onto your circuit. There's also transistors, which transistors are basically electronic switches. Your tablet or computer is actually using transistors right now to control the screen in such a way that it mimics the recorded movements of my mouse, and of course everything else happening on the screen, like for example scrolling up and down, and yeah. The difference between the two is that I don't know which one is which, but one is inverted, and one is basically you turn it on, it switches on the thing, you turn it off, it switches off the thing. And yeah. There's also phototransistors, there's resistors, which of course there's tons of types of values, like they go all the way up to 100k resistors. Now this is the rover which I was talking about. And as you can see, there's sort of hexagon shapes on there, and you can fit your circuit that you've built onto there, and then on the back there, there's snaps which you can hook up your wires to. There's that photo resistor. There's also adjustable resistors, basically potentiometers. These are not potentiometers that I know, but they're definitely this is more like a potentiometer design. I'll probably get that part too. We also have receivers for our RC Snout Rover. We have the slide switch, our press switch. We have a relay. Now, what a relay does is it will it's basically an electromagnet controlled switch. I don't quite know how you use it in a circuit, but still, it's a very cool piece. You've got a vibration switch, which I'm assuming if you like shake it really fast, it'll switch stuff on. There's also all sorts of different types of switches. Back there was a tilt switch. I'm guessing what that is. It's a sort of accelerometer, which, for example, is in your phone, which detects which way your phone is oriented. There's also speakers, which I guess it kind of wasn't misleading because there's two variants and the 32 ohm is yellow. So, but we got the I think it's 8 ohm speaker. Yeah. So I think they should hold true to what they're using, but still a transformer, which I'm not really sure what that would be. I'd have to do some more research on it, but you've got antennas, you've got all sorts of ICs. You also have these logic gates, which I showed you with the press switch and the slide switch, and these all react in the same way. You also have alarm ICs, and special to them, there's this IC which can which has its own specific socket. I'm assuming what it is. It's a programmable microcontroller. There's also another one right there. There's a color organ, and what a color organ does, I think I've watched a video on something similar to it. What it does is it activates an LED based on I don't know, decibels of music. I think there's a strobe IC. There's the infrared receiver, which there's one of those on our coming in our EV3. And this basically is the more exposed version of it. There's a keyboard, which I think is really cool because oh man, there's all sorts of things that you can use your voice for. There's an amplifier IC. I'm not really sure what that's for. Another thing I'd have to do some more research on. High frequency ICs, recording ICs, a motion detector, which I think I mentioned this sometime earlier in the video. It's for the detector lights outside of people's houses. Um, Sound and recording ICs, horns, the whistle chip, which reacts to sound when you like clap, for example. It will show you, or it will activate something based on it. And basically a bunch of replacement manuals. But yeah, lots of very cool parts. Yeah. Anyways, dudes, I think we're gonna wrap up the episode here. So glad you dudes have come down to your one-stop shop for everything. You name it. Snap circuits, resistors, capacitors, electromagnets, ICs, you name it, I'll use it, I guess, in this case. Hit that like button down below if or the dislike button, and suggest something else for me to do. Subscribe if you're new, and I'll see you dudes in the next episode.